Okay, so finishing out section 5.3, you want to be able to apply these same methods of finding z-scores to finding data values for other normal distributions where the mean is not 0 and the standard deviation is not 1. So you'll notice in the example we're looking at here, this is obviously not the standard normal because our mean is not 0 and our standard deviation is not 1. So I went ahead and kind of sketched out the normal distribution here based on the mean and the standard deviation. And notice I'm labeling this in terms of x, not z, because these are not values from the standard normal distribution. All right, now the next thing I'm going to do is look at what the question is asking. All right, I want to note right here, I'm being asked for a height. That means I need to find the data value and I am given an area because I'm asked for a percentile. So whenever you're asked for a percentile or a quartile, you always want to write this in terms of the corresponding area. And the 90th percentile, that just means the area to the left is 90%, which is what I want to use to find the corresponding data value. All right, so if we look at the area to the left and we take that to our standard normal table, all right, remember to look inside the table. If we take that to our standard normal table and we look for an area to the left of 0.9000, 90%, then that's going to be either 0.8997 or 0.9015. Now again, I want to get as close as I can. So the area that gets the closest to 0.90 is 0.8997. Now, remember what I can pull from that. What I can pull from that area using the corresponding row and column is going to be the z-score of 1.28, right? So based on that area, I know the corresponding z-score is 1.28. Now, if the question asked me find the z-score for the 90th percentile, then that would be my answer, 1.28. But it doesn't. It asks me to find the height, which means I need to find the corresponding value of x to answer this question. So what I'm going to do is I'm going to use my transformation formula. That's what you're seeing up at the top here. If I need to go from a z-score to a data value, then all I'm going to do is take the mean, in this case 69.4, plus the z-score, that's what I just found at 1.28, times the standard deviation at 2.9. All right, again, this is just mu plus z times sigma. That will convert this to a height, a data value, which in this case is going to be a height of 73.1 inches. And that is going to answer my question because that gives me a height corresponding to an area of 90%. And again, if I want to sketch this out, I can. Essentially, I'm asked to find a height, a value of x, where 90% of the area is to the left of this value. I did that by finding the z-score first and then converted that z-score back to a height, a data value, which was my value of x. All right, in the second example here, you'll see something very similar, only we were asked for the quartile, but notice I approached it the same way. Use the area to the left to find z, and then to take z and convert it back to a data value, I just use my transformation formula, which is mu plus z times sigma. And if you're wondering about StatCrunch, yes, you can use it here as well. You just have to make sure in these cases that you convert the curve using the proper mean and standard deviation. So in this case, I would put in my mean of 69.4, my standard deviation of 2.9, and then I just want to make sure that I'm putting in the proper area. So for percentiles and quartiles, it's always an area left. So I'm going to leave this less than. And then I'm going to put in the area in this box to the right-hand side. For the first quartile, that would be an area of 0.25. And then notice in my data value box, there's my height of 67.4. We got 67.5. Again, there could be a little bit of rounding difference, but we're finding the data value that corresponds to that given area. All right, similarly here, if I want the 90th percentile, I've got my mean and standard deviation. I put in my area, which is 90%, and then there's my corresponding height of 73.1. So the thing I want you to keep in mind, it does not matter to me which method you use, if you want to use the table or if you want to use StatCrunch. But either way, you've got to be very careful about knowing when you're given a data value and when you're given an area so that you use it correctly when you go to your table or you put it in the right spot when you use your normal calculator.